Hi friends, welcome to my another video. Today in this video I will discuss the important point mentioned in ADDC regulation related to distribution board. This could be final distribution board and sub-main distribution board and main distribution board. So in this video I will cover the key point, the major important point mentioned in ADDC regulation related to distribution board. So let's start this topic. The first point mentioned in the ADDC regulation related to distribution board is that all the distribution board must be factory assembled and there should be a type test for the all distribution board. I will cover the type test in one of the video in upcoming video because this is very vast topic and we should, being an electrical engineer, we should know what is type test, because for all electrical equipment, whether it is a MV switch gears, LV switch gears, even it is cables, all require type test. So I will cover this type test in any upcoming video, but as of now, as our topic is distribution board, so as per ADDC regulation it is mentioned that all the distribution board should be factory assembled and it should have passed the type test, okay, and it should comply BSEN 61439 standard as per ADDC regulation. The second point mentioned in the ADDC regulation is that the final distribution board, including the incoming cable, will normally be sized in accordance with the connected load. This is very important point. As per ADDC regulation, the final distribution board I am telling about, okay, the designing of the final distribution board must be as per total connected load, okay. But here you see it's mentioned for other distribution board. What is other distribution board apart from final distribution board? It is sub-main distribution board and main distribution board, right? Other distribution board may be sized in accordance with the diversified load. So what is the conclusion of point number 2? The conclusion is, for the final distribution board, the designing is by considering the total connected load, but the designing of SMDB and MDB is by considering diversified load. Hope you are clear till here. Now let us move to the other point. Each distribution board must have a neutral bar which is mounted on a insulator and which has a sufficient number of terminal points for adequate size for the larger cable expected to be used. What does it mean? As we know, there will be a distribution board and it will have bus bars, okay, it will have bus bars and there will be outgoing circuit breakers. I am telling any distribution board. I didn't specify it is final or final distribution board or main distribution board or sub-main distribution board. For any distribution board I am telling, there will be bus bar, there will be outgoing breaker, there will be incoming breaker and there will be a neutral link, okay. This point is related to this neutral link, that it should be mounted on the on a enclosure by using insulators and it should have sufficient number of ports in order to terminate all the neutrals of each outgoing and incomer. Now let us move to the other point. Each distribution board must have earth bar which has a mean of connection to the incoming earth conductor and cable gland and of the incoming cable. What does it mean? Same way, for any distribution board, final distribution board, sub-main distribution board or main distribution board, there will be bus bar, there will be outgoing breaker, there will be incoming cable, there will be neutral link, as well as there will be a earth link. Okay, and this earth link should have provision for the all outgoing loads earthing, as well as incoming cable earthing, and it should have provision for the gland earth also. I hope you are clear with this point. Now let us move to the other point. This is very important point. There is three cases: case number 1A, case number 2B, case number 3C. What it is saying, in case number 1, 2 or more bus bar section each protected by RCD. What does it mean? Suppose I have one final distribution board. This time I am talking about final distribution board only. Okay, so we have one final distribution board. There will be one isolator and 2 RCD. Okay, in the first case, case A, it is saying that it should have 2 ELCB or RCD with of 100 milliampere rating or 30 milliampere rating, or it could be both, could be 30 milliampere rating. But what is the important point to observe, that 2 or more bus bar section each protected by RCD. So there will be 2 bus bar section and each section is protected by 1 RCD. And suppose one load related to this ELCB have the earth fault, so this ELCB or RCD will trip and this RCD will be functional. So suppose this final distribution board is serving one area, and due to earth fault in one of the load, it will trip one section, but due to the another functional ELCB, that area will be served. So this is the first point mentioned. Okay, what is second point? Second point is saying that one bus bar section with individual RCBO fitted in the final distribution board. This is one kind of final distribution board where we have 2 section which should have 2 RCD and 2 bus bars. Each RCD will control 1 bus bar sections. So at the event of earth fault condition, the served area will have partial blackout and partial will be live because of other RCD is functional. Another final distribution board, it is saying that we can have final distribution board with isolator, and there will be RCBO direct. RCBO, what is RCBO? RCBO is the combination of MCB plus RCCB. Okay, so each of the load will have individual ELCB because each RCBO is a combination of MCB and RCCB. So each of the load will have separate MCB and RCCB. So in the event of earth fault, that breaker will trip only and other breaker will be functional. So as per ADDC regulation, there is 3 type of distribution board. I covered first point. Okay, I covered second point. The second case will be, there will be isolator and there will be RCBO. RCBO is a combination of MCB and RCD. So in the event of earth fault, that breaker will trip and other will be functional. Now let us move to the third type of final distribution board. Here it is mentioning 2 or more final distribution board together to serve an area. What it is saying, suppose we have to serve this area, so we have to use 2 final distribution board. Okay, one distribution board will feed power loads and one distribution board will feed light load. So this will be one bus bar section area, so there will be one ELCB and as it is feeding light source, so it will be 100 milliampere. This final distribution board serving this area for the power load, so there will be one ELCB section. As it is serving power load, so it will be 30 milliampere. So there will be, so what is the conclusion? There will be three type of final distribution board as per ADDC regulation. One with have two section with two different or same rating of RCD. Second one, there is no RCD, only isolator and RCBO. And the third one, in order to serve same area, we can use two individual DB, one with 30 milliampere rating and one with 100 milliampere rating. Hope you are clear. Now let us move to the other point number 6. Final distribution board should have limited to a maximum capacity of 14-way 3-phase or 42-way single phase. What does it mean? Suppose I have a final distribution board, okay, and it has two RCD. Each RCD is controlling separate bus sections, and we have outgoing breakers. Okay, suppose this is one outgoing breaker, this is another outgoing breaker. Same way there will be a outgoing breaker. Suppose this is one section and this is another section. This section is controlled by this RCD and this section is controlled by this RCD. Hope you are clear. Now the each section should have maximum 42 nos single phase MCB or outgoing. Each section, so this section also will have 42 nos single phase outgoing. So what is the point number 6? It is saying the limit for the outgoing breaker, single phase outgoing breaker, maximum we can keep 42 nos with each section. Hope you are clear now. Now let us move to the other point. Point number 7. Single phase distribution board may be permitted in a premises where the adequate provision is made for balancing the total load at the electrical intake between the three phase. What does it mean? This point is saying we can use single phase distribution board, but we have to take care the balancing of overall load. Then only we can go for single phase distribution board if we can do the proper balancing between the three phases. Apart from that, there is one more point. Suppose this DB have a load of 10 kilowatt. 10 kilowatt or below, we can go for single phase DB. But if the total load on this DB is more than 10 kilowatt, then we have to go for three phase DB only. So there is two conditions to satisfied to have single phase final distribution board. One is we have to maintain a proper balancing between R phase, Y phase and B phase. Then we can go for single phase distribution board. And the second point is that the load on the final distribution board must be less than 10 kilowatt in order to use single phase distribution board. Otherwise we have to go for three phase distribution board. Hope you are clear now. Now let us move to the other point, that is point number 8. The phase and neutral conductor in the distribution board shall be same cross section area. As we know, for any distribution board we will have R phase bus bar, Y phase bus bar, blue phase bus bar and neutral bus bar. The cross section of the phase bus bar and the neutral bus bar should be same for any distribution board. For any, I am telling for final distribution board, sub main distribution board or main distribution board, The cross section area of the neutral bus bar should be same as the other 3-phase bus bar. Hope you are clear now. Now let us move to the other point number 9. This is very important point. All the outgoing circuit of the distribution board must be provided with only circuit breaker, okay, and shall not contain fuses or any kind except for capacitor bank. This is very important point, and it is valid for all distribution board, whether it is a final distribution board, sub-main distribution board, or main distribution board. What is saying, in case of final distribution board, I will categorize it so you will understand better. Suppose it is a final distribution board, the outgoing load will be fed from breakers only. It should not be fed from any isolator, okay. The outgoing load must be fed from breakers only. But as we know, the main incomer of the FDB shall be isolator, okay. So this point number 9 saying, for any kind of distribution board, the outgoing load shall be fed from the breaker. But suppose in this case it is not FDB, it is SMDB. Then as I told you, for irrespective of the panel type, the outgoing load will be through the breaker. But as it is a MDB, then this time the incomer won't be isolator. This time the incomer will be MCCB. And it is valid for the main distribution board also. What is it? That the outgoing load will be through breakers, no doubt, but the incomer will be either MCCB or ACB in case of main distribution board. But irrespective of the panel type, the outgoing load will be fed only by the breakers only. The incomer is changing based on the distribution board type. For final distribution board, it will be isolator. For SMDB and main distribution board, it will be isolator. It will be breaker. Hope you are clear this point. This is very important point. Now let us move to the other point mentioned in the ADDC regulation related to distribution board. The incoming device of the DB may be isolator switch where adequate fault protection is provided by the upstream protective device. What does it mean? As I explained you just now, that for the final distribution board, the incomer can be isolator. But we know that this will be fed from somewhere. Suppose it is fed from the SMDB by one of the breaker. So this is the downstream breaker for this breaker. So this is downstream breaker and this is the upstream breaker. So here we fix isolator, but the upstream breaker for that isolator must be breaker only, okay. So the protection is not provided here, but it will be provided by the upstream protection by using breaker. Hope you are clear now. Now let us move to the other point. What is it? Distribution board of rating 200 and above shall be installed in a dedicated room. Distribution board of rating below 200 ampere shall be installed in a cupboard on any suitable enclosure. What does it mean? Let me explain you. Suppose I have a sub-main distribution board and the incomer rating is less than 200 ampere. Then as the incomer rating is less than 200 ampere, we can install this sub-main distribution board at any places, any suitable places, like in common passage, corridor, any inside the cabinet. But if this sub-main distribution board having an incomer rating greater than 200, then we have to install this sub-main distribution board inside an electrical room, inside a dedicated room. But there is a twist also here. Suppose in the point number 12 it is mentioned that main distribution board of rating 200 and above shall be located in the electrical intake room. What does it mean? Suppose this time it is not SMDB, it is main distribution board which is receiving power from the authority. Then, and suppose the rating of this incomer is greater than or equal to 200, then this must be inside the electrical room. In the SMDB case, suppose this rating is 200 and above, we can install in a dedicated room. It could be any room, okay, not specified that it should be electrical room. But suppose 200 ampere is the breaker rating for same panel, but this time it's not SMDB and MDB, then it should be in the electrical room only. Hope you are very clear with this point. Now let us move to the other point. Distribution board must be provided with sufficient number of protective device so as to enable every outgoing circuit to be connected to an individual protective device, and shall include not less than 10% spare protective devices and blank space. What does it mean? Here, as I told you, suppose I have a distribution board and it have a number of outgoings, okay. So number of outgoing must be adequate to feed all outgoing loads. First point. Second point is saying there should be blank and spare breakers. There should be spare breakers, or space should be not less than 10% of the total number of outgoing breakers. Hope you are clear that. Meaning we have to maintain 10% spare plus blank spaces in the FDB. Now let us move to the other point. Point number 16. Sub-main distribution board should be limited to 18-way 3-phase. What does it mean? Suppose I have a SMDB, okay, then the maximum number of outgoing for one SMDB can be 18 only. If we have more loads, then we have to divide this load into 2 SMDB. Hope you are clear now. But the maximum number of outgoing we can feed from one SMDB is 18 only for 3-phase. If we have single phase combination, so we have to use, like suppose I have 17 3-phase, then we can use 3 single phase. So 3 single phase will be considered as a 1 3-phase. So we can, means it's a combination. So total 18 3-phase load we can supply from one single sub-main distribution board. Hope you are clear now. Now let us move to the other point. The maximum, this is very important point, the maximum load allowed on a DB is 80 kilowatt. What does it mean? Suppose I have a FDB, final distribution board, and the total load connected to this distribution board reaches 100 kilowatt. In that case, we cannot feed this 100 kilowatt of load from 1 dB. We have to share this load. So what we will do, we will use 60 kilowatt from this final distribution board, and other 40 kilowatt we can supply from other distribution board. It can be anything, but one distribution can feed only 80 kilowatt of load. Hope you are clear with this point. This is very important point in the ADDC, and it is common for DIVA also. Now point number 18, single phase distribution board can be considered up to 10 kilowatt. Above 10 kilowatt we have to use 3-phase. This I already explained you. Point number 19, the short circuit withstand rating for the distribution board should be 6 kilo ampere or 10 kilo ampere. This is a general term, but we have to go for the calculation for the short circuit, prospective short circuit calculation, and based on that there will be a short circuit withstand rating for the final distribution board. But in general, when you will calculate, in 99.9 cases it will lies between 6 kilowatt to 10 kilowatt, but it is not accurate. I am telling you again, we have to go for the short circuit fault calculation. and I already made a video on the prospective short circuit fault current calculation for each level, at the transformer level, at the MDB level, at the SMDB level, at the final distribution level, and at the load level. So go and watch this video, you will understand this topic very well. The maximum incomer for the FDB is 125 ampere. What I said? The maximum incomer rating should be 125 ampere. I hope you enjoyed this part 1 video in series of ADDC regulation related to distribution board. I will cover other all important points related to distribution board in part 2 video, and that will be the final video in this series. Part 2 video will be the final video in this series of ADDC regulation related to final distribution board. Most of the point I covered in part 1 video. I hope you enjoyed this video. If you really like this video and find this video informative, then please hit the thumbs up button, subscribe to my channel, press the bell icon, and share this video with your electrical friends. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.